Hello everyone, let's try to be a cheat code ninja today. In this problem, we are going to see a very uncommon programming pattern in which we try to reverse fit some solutions and see if they are valid or not. So let's begin with the problem statement. We are given some packages and their weights, and we have to load those packages on a ship in the given order. It is also given that we cannot load any more weight than the capacity of the ship. And finally, we are also given the maximum number of days in which we can load all the packages onto the ship. Using all these values and conditions, we have to find the least capacity of the ship such that we can load all these packages in the given time period. Let's try to understand this problem using the given example. It's given in this problem that we have to load all these packages in at most 5 days. It's also given in the problem that we have to load these packages in the order given. Hence, we cannot be greedy and try to optimize the most number of packages for a particular day. So for a particular day, we can only choose packages that occur in order. So when the ship's carrying capacity is 15, on the first day we can load these 5 packages. The total weight will be 15 and we are not exceeding the carrying capacity of the ship. On the second day, we can choose only these 2 packages such that their weight is only 13. And on the third day, we can choose only one package with its weight 8. And if we try to add 9 into it, then the sum will be 17, which will exceed the carrying capacity of the ship. Similarly, on the fourth day, we can only choose one package with its weight as 9. And again on the fifth day, we can choose the last package with its weight as 10. So we can see that if the ship's carrying capacity was 15, we could load all the packages in 5 days. And you can try for other values and see that this will be the minimum weight that will allow all the packages to load in 5 days. Let's see the intuition and also the pattern to solve such a problem. Let's use the same example. So guys, whenever you see a problem in which you have to either maximize or minimize something, there's one programming pattern that should always be on the back of your mind, and that is binary search. We have already covered some problems in the past that use this pattern, and I would highly suggest you to look at those problems to get a better idea about this. So guys, let's see some conditions to determine if binary search will be allowed on a certain problem or not. The very first thing that we'll need to determine is if we can find a range for the possible solutions for a problem. Let's see if we can find the range of the possible solutions for this problem. Let's first identify the minimum weight capacity of the ship for a valid solution. So the best case scenario for us is that we have n packages and n days to load those onto the ship. So in this scenario, we just have to load one package per day. And for this to be possible, the minimum capacity of the ship must at least be 10. This is because the ship must be able to carry a weight of 10, which is the maximum of all the packages. In general, our minimum valid solution must be the maximum of all the packages. Because if it is lower than that, we will not be able to carry the most heavy item. Similarly, let's try to find the maximum valid carrying capacity of the ship. This will happen when we have n packages and only one day to load all those packages. Since the ship has to carry all the items on one single day, its carrying capacity should accommodate the sum of all these items. In general, this maximum value will be the sum of the weights of all these items. So for this problem, we were able to find the range of all the possible solutions. So this is only the first condition to check if a binary search can be applied or not. Let's have a look at the second condition. So for the second condition, given a weight or in general a value, we have to determine if we can even check if it's a valid solution or not. So let's see if we can do that using a random weight of 12 from the given range. So on the first day, we can choose these 4 items and their sum will be only 10. On the second day, we can only choose these 2 items. And from the third day onwards, since the items are heavier, we can only load one package per day. So this will take 6 days in total and will exceed the allowed time period of only 5 days. So we were able to determine if a random value from the range is an invalid solution. Now let's check if we can determine if a value is a valid solution or not. On the first day, we can load these 5 packages and their sum will be only 15. Similarly, on the second day, we'll load only these 2 packages. And similarly, on the third and the fourth day, we'll load these packages. So we can see that for a carrying capacity of 20, we could load all the packages in only 4 days. This is less than the time period allowed of 5 days. Hence, this will be a valid solution. So guys, now we have met both the conditions required to apply a binary search. Let's see this with a complete example. Our initial lower and the higher range of the binary search will be 10 and 45. And on the first iteration, we'll take the middle of them and check if it is a valid solution or not. We see that this is a valid solution where we could load the packages in only 3 days. And since we have to find the minimum possible solution, we'll try to look for a lower solution. So we'll update our higher range to be 1 less than this value. So the new value that we'll be checking for will be the middle of this range. And now we can see that even this is a valid solution. And so we'll try to look for further lower values. So our new upper range will be 1 less than this value. The new value that we'll be checking for will be the middle of this range. We can see that for a carrying capacity of 13, this will not be enough to load all the packages in 5 days. Since this is not valid, any number lesser than 13 will also not be valid. So now we should try to check for values which are more than 13. Hence we'll update our lower range. For our next middle value of 15, we know that it's already a valid solution. So we'll update our upper range to look for values which are lower than 15. And now for our next middle value, we can see that it is equal to both the lower and the upper range. So this will be the last value that we'll be checking for. This will take 6 days in total to load all the packages, hence this will be invalid. And out of all the valid solutions, 15 was the minimum, so that will be our answer. The time complexity of this would be, our range of the binary search will be the sum of this array, hence the binary search will take log of the sum. And for each value in this range, we have to check all the numbers in the array, so the total time complexity would be n into the log of the sum. For the space complexity, it would be constant because we are only storing the lower and the upper range. Let's implement our binary search solution. The first thing that we'll need is to keep 2 variables for the lower and the upper range. We know that the lower range will be the maximum of the array because our ship must be able to carry at least that much weight. And for the upper range, it will be the sum of the array. We already know that if the carrying capacity of the ship will be the sum of the weights, we could load all the items in only 1 day. So we'll initialize our answer to be that and then try to minimize it. Now we'll implement our binary search in a while loop. And this search will only be valid till the lower range is less than or equal to the upper range. We'll now check for the middle value for this range. We can find that by adding the range and then integer dividing it by 2. And if this value is a valid solution, in that case we'll update our answer. And since we have to minimize our solution, we'll try to look for lower valid solutions. Hence we'll update our upper range of the binary search. And if our middle value is not a valid solution, that means any value lower than it can also not be a valid solution. Hence we'll update the lower range of the binary search to try for valid solutions which are greater than our middle value. And once we are done with the binary search, our result variable will have the minimum possible answer and we can directly return it. But before we complete our solution, we have to implement our check function. This function checks if the total capacity for a ship will result in a valid solution or not. We know that even if we load all the packages on a single day, we'll still need at least one day. Now let's keep a variable to store the weight of all the items that we are going to load on a current day. We'll initialize this to be 0. Now we'll go through the weights of all the items. We can only load our current item if by adding it we are not exceeding the total capacity of the ship. So the sum of its weight and the weight of all the items being loaded on the current day should not exceed the capacity. And if it exceeds this, that means we'll need an extra day to load this item. So we'll increment the number of days needed by 1 and reset the weight for a current day to be 0. And finally, let's not forget to add the weight of our current item to the total weight being loaded on this current day. And finally, when we have counted the total number of days needed to load all the items, we'll check if the number of days required is less than or equal to the maximum days possible. In that case, this will be a valid solution. We are now done with our solution. I will suggest you to look at the binary search playlist to solve more such problems. If you have any doubts, concerns, or feedback regarding this solution, please mention in the comments. I always make sure to reply to each and every comment on this channel. If you thought this video was helpful, please leave a like and subscribe to this channel for more such content. Thanks for watching, guys.